Right, now for part B, you're given y prime prime plus 2y prime equals 2x plus 5 minus e to the power negative 2x. So we want to solve this non-homogeneous differential equation. Now we know that the general form of this should be y equals yc plus yp. Now we're going to start by finding yc. So that's the first step, step 1, to find yc. Now to find yc simply implies solving the associated homogeneous differential equation of the non-homogeneous differential equation. Now the associated is when the right hand side is 0. So we want to solve y prime prime plus 2y prime equals 0. Now to solve this, the first step we do is we find the auxiliary equation. For the auxiliary equation, represents the dependent variable by an algebraic term, which I'm going to choose as m, and then this just replace them the way they are, but in terms of by numbers anyway. So plus 2m equals 0, and then when you solve that, you either have your m to be 0, m1 to be 0, and your m2 to be negative 2. Now those are the two values of m that satisfies this differential equation after it's been solved. Now since the two of them, since they are distinct, we have that the general solution of the complementary function, which is the general solution of the homogeneous equation, should be c1 plus c2 e to the power negative 2x. So this is what we have for our yc. Now the next thing is we want to find yp. Now how do you find so we want to find yp. Now how do you find yp? So since we're using the method of undetermined coefficients, the superposition approach, we're going to assume a form for a particular solution. So to assume a form, the form we're going to assume is going to be dependent on what we have on the right hand side. Let me call my right hand side, let me call it g of x. So you have 2x plus 5 minus e to the power negative 2x. So what I'm going to use to represent my g of x is dependent on what I have here. But then what you have here is, there are two terms here, two kinds of family. This is a linear family and this is an exponential family. So to write the assumed form for this, since this is linear, so my assumed form is going to be ax plus b, and then since this is the exponential family and it's just an ordinary, just 1 times e to the power negative 2x, so I'm going to use c e to the power negative 2x. This is the assumed form for my particular solution. But then before you begin to use the assumed form, which I'm going to call yp, before you use this, so you need to compare. You compare this the terms you have. So this is going to be my yp1, and this is going to be my yp2. So this is a part of my particular solution. What's the second part? Because they're not families anyway. So this is the linear part, this is the exponential part. Now, before you begin to use the particular solution or the assumed form of the particular solution, compare the terms in each of this family and ensure that they have not been replicated in the complementary function. So I'm going to start with yp1, the linear part. So for the linear part, I have a multiple of x here. Do I have multiple of x here? No. I have a constant here. Do I have a constant here? Yes. Now, whenever you have a twin, you multiply that family by x. I go to the next part. I check. I have a multiple of e to the power negative 2x here. Do I have a multiple of e to the power negative 2x here? Yes. A constant multiple, a constant multiple. So to avoid replication, I multiply this part to by x. Now, I should have used different colors there. So this is by x and this by x. So doing that, the new assumed form is going to be yp equals, so x times ax is going to be ax squared plus bx plus cx e to the power 2x. Now, before you even begin to use this new one, you need to recheck that there has been no repetition. So again, we have two things. We have yp1 and then we have yp2. So for the first one, I have a multiple of x squared here. Is there a multiple of x squared here? No. I have a multiple of x. Is there any multiple of x here? No. So this is fine. So this is fine. I go to the next one. So you have a multiple of x e to the power negative 2x here. Do I have a multiple of x e to the power negative 2x here or here? No. Since we do not have, this is also fine. But assuming we had, we would have multiplied only this part by x. So now since they do not have any twin, then we are fine. So that means that is going to be the assumed form. So let me just write it in full. Let me just write it boldly. Yp equals ax squared plus bx plus cx e to the power negative 2x. This is going to be the assumed form of particular solution that we would use. So the next thing is, since we are assuming this is the particular solution of this non-homogeneous differential equation, it implies that by the time we substitute it into here, it must satisfy this differential equation. Now to make the substitution, I need to find y prime and I need to find y prime prime. So since I already know this to be my yp, now my yp prime is going to be 2ax plus b, then plus c into the power e to the power negative 2x, then plus cx, so just applying product through there, minus 2, this will be minus 2e to the power negative 2x. Then we find the second derivative, y double prime, so which is going to be 2a minus 2c e to the power negative 2x minus 2c e to the power negative 2x plus, now I hope we've not skipped something here. So we have yp prime to be 2ax plus b, and this is c e to the power negative 2x plus cx into minus 2 e to the power negative 2x. That's what we have. Yeah, so we have 2a, then this. Alright, we are fine. Then minus 2c, then plus 4cx e to the power negative 2x. Just trying to cross check that we do not make any mistakes, since I know most of you are going to want to check these things, so not to confuse anybody. Alright, now we already have that. Now the next thing is we want to substitute it into what we have here. So I want to make a substitution here, so I'm going to use that dE. So making use of that dE, so what we have is we have y prime prime plus 2y prime, so which is the sum of this and twice of this, and what we have is 2a plus 2b plus 4ax minus 2c e to the power negative 2x. Now this should give us the right hand side, which is 2x plus 5 minus e to the power negative 2x. So you might want to look at it this way. So you have your constants, which is 2a plus 2b, and then you also have the coefficient of x here, which is 4a, and then you also have the terms, the multiple or the coefficient of e to the power negative 2x, which is e to the minus 2c. So also here, the coefficient of e to the power negative 2x here is minus 1. You can see that minus 1, and the constant that we have there is plus 5, and while the coefficient of x there is just 2. So we compare coefficients now. So compare coefficients. So when you compare coefficients, what we would have is 2a plus 2b, the red to red, equals 5. Now this color to this color, so 4a equals 2, and then the coefficient of e to the power negative 2x is minus 2c equals negative 1. Now when you solve this whole thing, what you'd have is your a to be half, your b to be 4, and then we'll have our C to be 1. Now since we have this, our A to be this, our B and C to be this, now there is one part where most people might make mistakes. You already have different variants of your YP. We started with this, we came here, and then we have this finally. Now this is the YP you use. It's the final form of the YP you use, not the initial one you started with. We're doing a trial and error to find the exact one that works. So this was the one that works. So you don't have anything to do with the past ones which you assumed. So that's going to be the YP. So using this, so we have our YP now to be, we have AX squared. So our A is half. So it's going to be half X squared plus BX. This is B plus 4X. Then plus C as 1 x e to the power minus 2x. So that is our YP. And then in conjunction with the YC we had earlier on, this is our YC. So since YC plus YP, so now we have our general solution, which is Y. So therefore Y, which equals YC plus YP, equals C1 plus C2 e to the power negative 2x, then plus our YP, which is half x squared plus 4x plus x e to the power negative 2, right? E to the power negative 2x.